All right, hey gang. Excuse me. Uh, got so excited, got a little choked up here at the beginning of the chapter 7 review. Anyways, hey, I want to go over two problems that I think are going to give people the most difficulty on this review. Okay, and so as I go over them, just listen carefully to what's going on, and yeah, hopefully this will help you prepare even more for your chapter test. So let's get after it. Taking a look at the first thing. Let me actually adjust my camera so we can see that just a bit better. Okay. What I want to look at here is the problem at the bottom of the page on the front side. Okay. It says here, redraw the three triangles separate from each other and label all the parts. So the reason why I'm having you do this is so you can see how each part matches up. And so as you look at this, I'm going to redraw the big triangle first. I'm going to label that right angle right there. Then I'm going to draw the little triangle off to the side over here. Label the right angle. And then I'll do the same thing with the medium-sized triangle. Okay. Now, what I want you to know about these triangles, all we know are the two sides, 8 to 8. Okay, that's all we really know, and then we have to figure out the variables x, y, and z. And so what I want you to know is that these triangles are going to be similar. Notice those angles are the same angles. Okay, they all come from that angle right there. These angles right here are all the same angles as well. They come from this angle right here at B. Okay, the triangles are similar by angle-angle similarity. So I'm just going to go ahead and circle that angle-angle similarity. Now from here, I have to set up the triangles in a similar fashion. So if I do A, B, C, notice how they're marked. Right angle, one congruency mark, two congruency marks. If I go to, let's say, this triangle here, right angle, one congruency mark, and if two angles from two triangles are congruent, the third angles have to be congruent. So I'm going to put down two congruency marks there. So I'm going to do DBA. And then the last one, again, if these two angles are congruent to these two, the last angles have to be congruent. Okay, so again, right angle, one congruency mark, two congruency mark, I'm going to say DAC. Okay, so this picture, this image is actually more complicated than what I'm going to probably give you on the test. Okay, it's just more involved, and so I want you to know that. We also notice in the directions here it says simplest radical form. Well, that is also something that we're actually going to cover more in next chapter. So just pay attention. This is kind of a good intro to the next chapter, and hopefully all this will make sense to you. So to finish up the problem, I'm going to put down that this length right here is x, this one's y, and this one's z. And I'm going to put that this length is y, and that this one is x plus 2. We're adding the two segments together to get the full length right there. Okay? Now, what I would probably do first is probably solve for z. I'm looking at this right triangle right here, and I'm thinking to myself, hey, I know two of the three sides. So what can I do to figure out that third side? I can do the Pythagorean theorem. So I'll go ahead and do, now 8 is my hypotenuse, so I'll start with that. And then z and 2 are the legs. So I'll put those as a and b. Okay. So if I square 2, I get 4. If I square 8, I get 64. And if I subtract 4, get that 4 over to the other side, I get 60. And if I square root 60, that is z. Okay? Now, in order to figure out if I can factor this out, I'm going to go ahead and put down all the factors that I can multiply together in their smallest form to make 60. So I know 2 goes into 60 30 times. I know 2 goes into 30 15 times. I know 3 goes into 15 5 times. So this right here, 2 times 2 times 3 times 5, 4 times 15 is 60. It's still the same number. I've just written it out in an expanded form. Now, whenever you have duplicates, and we've talked about this earlier this year, it comes out as one number. So I'm going to put down that z is 2 radical 15. Okay? Now, one way to double check your answer would be to go ahead and plug that into your calculator. So I'm going to go ahead and do this with my calculator. It tells me it needs charged. The square root of 60, and then 2 radical 15. Okay. Now, I could have done this quicker. I could have said 4 times 15 is 60, and the square root of 4 is 2. Okay? But again, if you're just learning to do radicals, sometimes it's best to break it down into its smallest form and pull out any doubles as a single. Okay? But that is a perfect square of 4. So now I know that z is 2 radical 15. 2 radical 15. Okay, again, there won't be any radicals in the test, so don't be concerned about that. If I wanted to find another variable, I guess I'm looking at these two triangles here and thinking, hey, I could find x by doing this. This 2 corresponds with 2 radical 15 over there. Okay, and this 2 radical 15 here, this z, corresponds with the x. Okay, and so in the end, we can go ahead and cross multiply and solve. Now, yeah, I'll just go ahead and cross multiply. I'll show you how to work these radicals here. This makes 2x. This makes 2 radical 15 times 2 radical 15. Okay. Now, we want to multiply the like terms. So 2 times 2 is 4. So this gives us a 4. And radical 15 times radical 15, I'll type that in my calculator so you can see what's going on. Okay, it's just 15. An important thing that we will cover later on is that any radical times itself is just that number. Okay, because what this gives me is the square root of 225. 15 times 15 is 225. And if I take the square root of 225, it gives me just that number. Okay, so what we have here is actually 4 times 15. Okay, and that ends up being 60. Now, we shouldn't be surprised by that, because if I square this, okay, it gets me right back to here, because unsquaring radical 60 gives me just 60, okay? So, to finish this off, dividing by 2, x will be 30, okay? Now, to find y, now this whole length here, understand, is 32, so just be aware of that, okay? To find y degrees, I'm going to do something like this. Let's do 2 is to 2 radical 15 as the hypotenuse here, 8, is to the hypotenuse there, y. Okay? Now, I will tell you this. I could have reduced my fraction over here and taken the 2's away. Say they're gone. I could take them away right now, but I'm not going to, because I'm going to show you something. So I'm going to put 2y is equal to 8 times 2 radical 15. Okay? Now, one of the important lessons I will teach you later on is that these radicals, we treat them we treat them just like variables. So I'm going to go ahead and do 8 times 2x here. Well, that equals 16x, right? So the same thing is true here. I have 2y equals 8 times 2, 16 radical 15. Okay, treat it just like the variable. Notice how the x came all the way through the problem there. Same thing with the radical 15. Now, in order to get y by itself, you're going to divide by 2. And so y will equal, now you only divide like terms. So the radical has nothing to be divided by. And so we end up with 8 radical 15. Okay? So to check this, okay, let's do this. 8 times 2 radical 15. Go back to the very beginning right here. Now remember, I said it equaled 16 radical 15. Well, if you type in 16 radical 15, bada boom, bada bing, we get the same thing, okay? Now, from there, if I divide that by 2, 16 radical 15 divided by 2, we get that. If I type in 8 radical 15, we get the same thing, okay? So I hope that you're seeing how to calculate things with radicals there, all right? So again, our answer, x is going to be 30, y is going to be 8 radical 15, and z is going to be 2 radical 15, okay? A lot of work there, but that's why I wanted to show you that, how to work through those, okay? The last problem I wanted to show you to talk about was number 9, okay? So if I look at number 9 here, I need to find the length of BD. I did not identify what BD is, so I'll do something like this, B, C, and D, okay? D is that one right there. Now, if I'm trying to find BD, I'm actually going to label this X, because I want to find BD. Well, if that's X and this is 5, what does this length have to be right here? Or how do we find this length? Well, in terms of X, if we take the difference of the whole length from what's already given right here, what's left over should be this down here. And there you go. You have that length. Okay? Now, from there, you should be able to set up your proportion. Notice it's an angle bisector, or what we said about these sides. The angle bisector intersects the side opposite proportionally with the sides of the angle, okay? All right, I think that's it. That's all I wanted to go over. If you have any questions, let me know. Note it down there, note A is the original figure, so you're gonna have a number larger than 1 to get to B. So I appreciate your attentiveness. Hopefully I didn't discourage you too much. Again, there won't be one nearly as hard as the problem that I just showed you there. So I hope you have a great day. We'll talk to you later.